Okay, so assume that you've been given the points -2, +1, and then 3, 3. And you've been asked to find the line, so graph the line that passes through the 2 points, and then find the slope of that line. So the first thing we need to do is we need to actually graph the line. So we'll find the point -2, +1, right? Remember, this is our x, and this is our y. And we're going to move 2 to the left because negative is towards the left, and then up 1. So we get this point here. That's a bad color. Let me use a different color. So we get this point here. Okay. And then we have 3, 3. So we're going to move over 3 and then up 3. And we get a line that looks like it's going to pass through these 2 points. So let's draw this line. And we've got this line here, right? It's going to extend this way, and then we're going to keep extending it out this way, just like that. Okay, so that's a fairly consistent line. And we'll draw our points here like this, and then like that. All right, so we've got this line here, and they want us to find the slope of the line that passes through those points. Okay, now if you remember, right, slope is a measure of steepness. Okay, slope is your measure of steepness. How high or how fast really the line either rises or falls, and almost like you're going down a ski slope, right? The higher the slope, the more steep the slide is, or more steep the track is, or something like that, right? And we can measure the slope if we find the change in y, and place it over the change in x. Okay, so the change in y versus the change in x. And we can also say that this is the rise over the run of the line. Okay, so let's look at the rise of the line first. Okay, so we need to figure out how much it either goes up or goes down on the y-axis. Let me do this with a different color. So let's look at the first point. And in order to be in line with this point, so let's say point A, and then we have point B. In order to be in line with point B, if we move from point A, we have to go up 1, 2 to be on the same grid line. So if we want to get from here to here, right, we have to move a distance of 2. And we had to move a positive distance because we didn't go down, we went up. So our rise is actually going to be a +2. Okay. Now to run, right, we're not running in the air, so we're going to move from left to right if you're going to remember it that way. In order to get to point B, we have to move from this point here, and we have to move this distance here. And that's 1, 2, 3, 4, 5 grid lines. So we had to move a distance of 5 in the positive direction because we're moving towards the right over here. Okay. And our slope then is a distance of 2 in the y direction over 5 in the x direction. Okay. And if we were to write an equation for this, right, it's a little hard because the y-intercept isn't crazy good here. But we would have to write an equation that is in the form of y equals mx plus b, right? So if you ever see the slope of a line equation, actually really just the equation of a line, we have y equals mx plus b, okay? And the place that the slope goes is right here where this m is, okay? So m is equal to slope, okay, which is equal to our 2 over 5 in this case, all right? So if we were going to write a line equation, right, we'd have y equals 2 over 5. We'd have y equals 2 over 5 x plus the y-intercept of b, which we can imagine is pretty close to 2 right now, Okay, so we're going to say that that's 2, and that would be the equation of our line. All right. Now, a couple other things to notice is that this is a positive line. This is a positive slope. All right. And the reason we know it's a positive slope is because when we look at it's almost like we're reading it like a sentence. When we look from left to right, the line is rising. Okay. So if it rises to the right, okay, if it rises to the right, then it's positive. If it does not and it falls to the right, then it's a negative slope. Falls to the right. Okay? So if we had another line moving in this direction, so say we had a point here and then we had a point down here, right? Let's use another color. And we were to draw a line between those 2 points, right? We'd have a negative slope because as we look from the left side to the right side, it's getting smaller. Or at least it's dropping. It's getting into the negative area. And really it's going from quadrant 2 to quadrant 4. Okay? And typically a positive line will be over here in quadrant 3 and then move into quadrant 1. Okay? So a positive line rises to the right like our red line does, and then our orange line is a negative line, which means it's going to fall to the right. That also means that its m is going to be negative. Okay, so a positive slope has just a m, and then a negative slope will have a negative m as their answer. So because this is positive, this 2/5 is positive, that means that our line is positive. Okay? So let's assume that we had another graph. So why don't we say we had a graph here, make it down here, right? And we're just going to kind of sketch something in real fast. And it looks like this. And we were given a line that looks like this, okay? Straight across. So that purple line straight across. And let's say that it crossed the y-axis. Let's say it crossed the y-axis at, let's say 5. Okay, so y is equal to 5. Okay, this would be the equation of our line. And because it's a horizontal line, it doesn't slope at all, right? It's flat. We actually would say that the slope of this line is 0. Okay, the slope of this line is 0 because it's not going anywhere. There is no change. There's no change in y. So we'd have for any distance x, right? For any distance x, we would have a change of 0 in the line, which means that it's going to be no slope, okay, or 0, right? I guess it has a slope, so this isn't quite accurate. 0 is our slope, okay? Now, let's say that we had a line, we'll do blue, and it was going straight up and down instead. So instead of going straight left and right and it's flat, let's say that it's just straight up and down. Now, the problem with this here is that if we try to give a slope for this line, right, what we're going to have here for this line is we're going to have a slope and it changes infinitely, right, in a 0 change in x. So there's an infinite change in y, right? Because it's infinitely going all the way to the top, and it's also moving towards infinity to the bottom, but there's no change in y. So our slope is this fraction, right, is infinity divided by 0. Infinity is undefined, and anything divided by 0 is undefined. So our slope actually is undefined. Okay, there really isn't a slope. It's undefined. We don't know what it is. Okay, so we can't say that. The equation of this line, depending on where we were at, let's say that this was maybe 3, we could say that x equals 3, but that still doesn't give us a slope because x doesn't have a coefficient next to it. All right, it's just 3. So this is an undefined slope. All right. So when you're trying to find the slope of a line, you need to find the 2 points, figure out how far it rises or falls, and then figure out how far it changes left or right. And that will give you the slope of the line.